Here we have a structural Revit model, and if we spin around, you can see it's of moderate size. If we look at particular materials in this project, we look at a piece of steel which isn't actually segregated by floor, which should be later on. If we look at the structural material and look at the identity, this should be a metal at least class, and there should be steel somewhere in one of these keywords, descriptions or something like that. So straight away this model isn't very helpful for me. Similarly, if we look at the structural material of this concrete column, identity again, this should at least be concrete, and there's been very little information provided. This prevents me from looking at any of the physical or thermal properties which actually will become relevant outside of the structural usage potentially. So instead, the structural engineers in this particular project have provided additional parameters where they've actually stated all the different bits of materials and properties for that bit of concrete, which will turn up at later stages. If we look at the steel, they've also done that, and we're awaiting further information because this isn't a fully developed design. So if I go and open Dynamo, Dynamo is a visual programming package. And if we open the SMM7 one that I've used previously, it all looks quite heavy. We don't need those. So what is going on here is that we are using our SMM7 library, which is a DLL I've created, and within these sections we have beams, columns and walls. For instance, in G10 deals with metal structural columns and walls, whereas E refers to concrete. So within these individual nodes there is code which is actually trying to follow the format of what is SMM7. So this is SMM7, and we're looking specifically at the structural steel, G10. So columns, beams, bracings is all as per Revit families, but also we have to look for whether they're curved, tapered, castellated or cambered. So these are additional tests that we have to run to comply with the SMM7 rules of measurement. So looking at the specific code that is used to make these particular items, so we've got a G10 and its beams. We're looking through and we're actually selecting items which are on a created phase and remain at the end of the project. So we don't want anything demolished or temporary in this situation. And then we have to drill down slightly further to eliminate families that have no instances, and we're looking for specific type of beams. It goes through and starts populating the various fields in one of these takeoff items. So in this, as mentioned before, having to look through all the parameters, and if they're of that materials category, we're looking to try and extract some information for what is a level 3 description. It's D3, which is actually a dictionary set of values. So this is how we are converting Revit elements into an SMM7 structure. So you'll see at the top of our canvas that we are trying to export this data to Excel. So it's pointing to a file and a spreadsheet, and it's telling me where we want to put it. The specific spreadsheet in question is this one. So we have a template for the builds, we actually have an area for the takeoff schedule, and then we're going to condense that information into a data table. So after we run the macro, we're hoping that this populates. So if I go to run, this is in real time, you can see it working. So what it should be doing is working through all these different nodes I've got here, E10 beams, E10 columns, E10 walls, G10 columns, etc, etc. Looking at all those different tests that have been provided, and you see there's a watch which is provided an output. So if we look at our takeoff schedule again, you'll see that it's populated. So each node is actually producing an additional header row, so hopefully it can be split up. What we will need to do is actually run a macro to tidy this up and turn it into a table. So if we run populate data table from TOS, so the information in our takeoff schedule, which isn't in a table and has erroneous values, will be populated into unique values here, where it's going to sum identical aspects. So there may be many elements with the same descriptions, and it's going to combine them into a single entry. So now you can see that we've actually got a table from our takeoff schedule, and we don't have any additional headers. If we're looking there for the word project, it has none. It's actually just got the actual file name. So in addition to just having the filtration system, we're actually adding a bit more information. So with the node E10, refers to concrete beams, we're actually calling it concrete. But if we look at the other nodes, which is actually under G10, you see we've got structural steel. So this method is not just looking at the project where you would have several models in a single building and then they would need to be federated, so they may have different names. You may have a building split into different blocks. Again, this would be shown up in this project name. The discipline can also be changed, which should be part of the project. We have our packages, and then we have our different single items, and we have our GUID and ID within that project. This will be completely unique, and that will be unique to this project. So if we go across the data, it's actually looked and found unique instances of each one, and then sum the total of all of those. So just as a sense check, for this particular row we have found 53 items, and that totals 42.1 cubic meters of concrete. We have calculated the weight of concrete using the volume of each component, so we summed the volume and then times it up by the density of steel, which is stipulated in SMM7. So we have all of this information, but we need to push it into the traditional bill. So we can run another macro in this area, and that is generate BOQ from data table. This produces a prompt which asks us how we want to split this up. So in this case we're going to go by package, because we have ground workers and structural steel. We can export into separate sheets and PDFs, and this just refers to the style that we want Excel to use. So if I press run, that is now going to take that information from that data table and start producing individual Excel sheets which will be ready for exporting. So if you look, that was structural steel. We look down and we can see our various instances as per a traditional SMM7 build-up. So if you look at this, what is a level 3 item, so level 3, we're actually introducing some of the specification. So structural material says by category. I've referenced that that's an error where it's saying generic. We should actually pick more information. We could eliminate this from our description, but in this particular instance it's telling me it's steel of that quality. If we look at the groundwork and concrete, we should see we get something similar in terms of the level 3. So here we have concrete reinforced, and it tells us the grade. So this is how we can go from Dynamo, a Revit model, into Excel, and we have direct Excel packages.